In this video, we're going to be talking about the unit circle. The unit circle is just a circle that's centered at the origin and has a radius of 1. And you might think it has, pretty much no use, but in reality, it's actually very important. Now, hopefully y'all remember your trig functions, so this is just kind of a quick review. At first, it may seem impossible that you can take sine of, let's say, 135, right? An angle that is greater than 90 degrees. Because, think about it, right? In order for these trig functions to, do their thing, well, in order for them to be used, well, you need a right triangle, right? With 90 degrees. If you have a triangle where the angle is bigger than 90 degrees, so let's say if I form a triangle that's bigger than 90 degrees, well, it wouldn't be a right triangle anymore, right? If I were to try and make it a right triangle, well, this isn't really a triangle, right? 100. If you already have 135 degrees, you can't have another 90 degrees to the triangle because all of the angles in a triangle add up to 180. So, this just seems impossible that, you can take sine of angles that are greater than 90 degrees, or even equal to 90 degrees, in this case. So how do we do this? And we're going to be using the unit circle. Now, the unit circle, well, let's say that we have an angle. So let's say that we use this part of the x-axis as the base of our angle. So let's say this is the base of our angle. And we create an angle, right? So we create an angle theta. Now this ray right over here that we drawn to create this angle, it's going to intersect the unit circle at some point, right? It's going to intersect the unit circle at this point. And what we're going to do is we're going to draw an altitude down, or a 90-degree angle downwards, right? And this creates a 90-degree angle. So now we also know that this circle, I said in the beginning, the unit circle is a circle that's centered at the origin and has a radius of 1. This length right over here is equal to 1, right? Because this is a radius. Now you can all agree that this length right over here represents the x value of this point, right? This point, the x value of this point is equal to this length, right? So that length is equal to each other. And the y value of this point is equal to this length of this triangle, right? This length right over here represents the y value of this point. So, knowing this is the x value, this is the y value, and this hypotenuse of our triangle is equal to 1, what is cosine of theta? I want you to find out what's cosine of theta, this angle, and I want you to find out what sine of theta is, sine of this angle. Cosine of theta, we know cosine of angle is equal to the side adjacent that angle divided by the hypotenuse. In this case, the side that's adjacent to this angle right over here is going to be this side right over here. So it's going to be the adjacent side, which is equal to x, divided by the hypotenuse, which is going to be 1. What about sine of theta? Sine is equal to opposite over hypotenuse. So it's going to be the side opposite this angle, which is this y, which is the y value at this point, divided by the hypotenuse. X divided by 1 is just x. Y divided by 1 is just y. And from this, we can conclude that any point on this unit circle, so any single point on this unit circle, can be represented as cosine of theta, has the coordinates cosine of theta, comma sine of theta. Now, if that's confusing, think about it like this, right? We created a random angle, and the coordinate of our point right over here, well, the x value of our point is, we said that was cosine of theta, and the y value of our point, we said that was sine of theta, right? Therefore, the coordinates of our point is going to be x comma y, aka cosine of theta, comma sine of theta. I just did some substitution there. And it turns out that this works for any point on the unit circle. So for example, if I create a 30-degree angle, and, once again, it's going to hit the unit circle at this point, draw hypotenuse down, 90-degree angle, and I want to find out what are the coordinates of this point. Well, I could just say that's cosine of the angle that we created, so cosine of 30, comma sine of 30. That's going to be the coordinates of our point. Now, another kind of important thing to know is that we said how the x value is cosine of theta, right? The x value is cosine of theta. And the y value is sine of theta, right? We just said that. Now, cosine of theta represents this side. Sine of theta represents this side. And one represents the hypotenuse of our right triangle. And notice how, one thing you might be wondering is that, can you do the Pythagorean theorem? Like, hear me out, right? We have one side, cosine of theta, the other side, sine of theta, hypotenuse is 1. Can you do the Pythagorean theorem? And the answer is yes. This is something known as the Pythagorean trig identity. And it just comes from the Pythagorean theorem. It says that a squared, in this case cosine of theta squared. Another way you can write cosine of theta squared is actually cosine squared theta. Cosine squared theta just means cosine of theta squared, okay? These two things are equal to each other. But just for convenience, usually write it like this way, because it's easier instead of having to, put parentheses with a square on the outside. So cosine of theta squared, this side squared, plus the other side squared, sine of theta squared, or sine squared theta, is going to be equal to the hypotenuse squared, 1 squared, which is just 1. And this right over here is called the Pythagorean trig. So let's say that if cosine of theta is equal to 1/2, cosine of theta is equal to 1/2. Well, what's sine of theta going to be? You can imagine this it like this, right? So if you have, let's say, a triangle like this. So triangle like this, right? Where this is our angle right over here. If cosine of our angle now, to help visualize kind of what this problem is asking you, right? What it's basically asking you is if cosine of, in this case, our angle is equal to 1/2, right? Well, what's sine of this angle going to be? What's the side opposite this angle over the hypotenuse? What's that going to be? And in this case, instead of using kind of the Pythagorean theorem and doing all that, you could just use this Pythagorean trig identity, right? You could just say that cosine of theta squared, in this case, we know cosine of theta is 1/2, so it's going to be 1/2 squared plus sine theta squared is equal to 1. 1/2 squared is just 1/4. And if you subtract 1/4 from both sides, you get 1 minus 1/4, which is just 3/4. So you get sine squared theta is equal to 3/4, right? That's 1 minus 1/4. Now to solve, if we want to find out what sine of theta is equal to, what this is equal to, well, all we have to do is just take the square root of both sides. So we get sine of theta is equal to the square root plus or minus the square root of 3 divided by 4. We can rewrite this as plus or minus the square root of 3 divided by the square root of 4. Square root of 4 is just equal to 2. And we're not done yet because we're talking about the lengths of a triangle. And obviously the length of a triangle can't be negative. So it's just going to be, our answer is going to be positive, the square root of 3/2 as our answer. And sine of theta, yeah, that's square root of 3 divided by 2. And notice how if you do it this way, you can also do it the other way, right? You can say a squared plus b squared, in this case, if we call this side x, b squared is equal to c squared. You have 1 plus x squared equals 4. X squared is equal to 3. If we square root both sides, we get that x is equal to the square root of 3, because positive square root of 3, because it's the length of a triangle, right? And now we can just find sine of theta, right? So sine, we said how that's equal to the opposite side, the side opposite that angle, which is radical 3, divided by the hypotenuse, which is 2. And you notice how we end up with the same answer. Hopefully y'all memorized the 30-60-90 right triangle and the 45-45-90 right triangle, because y'all are going to need it. So In this case, right, 45, 45. This is an isosceles triangle, so these two sides are going to be the same length. And doing the Pythagorean theorem and some calculations, you're going to get that the hypotenuse is always x radical 2. So if these two sides are x, so let's say if I have a right triangle, let's say this is a 45, 45, 90 right triangle, and these two sides are 3, well, then the hypotenuse is going to be 3 radical 2. Hypotenuse is always radical 2 times longer than the other two sides. For a 30, 60, 90 right triangle, hypotenuse is always going to be 2 times longer than the side opposite 30. And the side opposite 60 is always going to be radical 3 times longer than the side opposite 30. So let's say if this is a 30, 60, 90 right triangle, let's say our hypotenuse is 4. Well, in this case, the side opposite 30 is always 2 times less than the hypotenuse, right? Hypotenuse is 2 times longer than the side opposite 30. So that means that this side has to be 2, and then the side opposite 60 would just be 2 radical 3. Radical 3 times longer than the side opposite 30. Now that we have that established, I need y'all, once again, y'all got to know these 3 triangles, all right? Y'all got to remember these 3 triangles by heart. Okay, so first thing, we're going to use, once again, this x-axis as the base of our angle. And we're going to draw, first case, a 45-degree angle. And remember that this length right over here, so once again, this ray right over here to create the angle is going to intersect the unit circle at some point. I'm going to draw altitude down. Remember that this right over here, this x value represents cosine of the angle, and this y value represents sine of the angle. Remember that. So when you have a 45-degree angle, and this is a right triangle, well, the other side has to be 45. Right? Remember back to like the 45, 45, 90 right triangle, right? If one side is 45 degrees and the other side is 90 degrees, well, we know that the last side has to be 45 degrees because all angles in a triangle have to add up to 180. So 45 plus 45 is 90, 90 plus 90 is 180. Now, we also said how the hypotenuse of our triangle is equal to 1 because that is the radius of the unit circle, and that is a radius. So, how can we find out the lengths of these two sides using what we just learned right over here? Well, we said how the hypotenuse is always radical 2 times longer than one of the sides, right? So if I want to get from the hypotenuse to one of the sides, well, all you have to do is just divide the hypotenuse by radical 2, right? If I want to get from x radical 2 to x, well, all you have to do is just divide by radical 2, right? So then I get to x. So in this case, I take my hypotenuse 1, and I divide this by radical 2, right? This is how you get from x, radical 2, back to x. So both of these sides are going to be 1 radical 2. 1 radical 2 here, and 1 radical 2 here. Because remember, this is an isosceles triangle, so these two sides are going to be equal in length. Right? So if one side's 1 radical 2, the other side has to be 1 radical 2. And if we rationalize the denominator, so if we just get rid of the radical in the denominator, we get that this is equal to radical 2 over 2. So this is equal to radical 2 over 2, radical 2 over 2. So when you create a 45-degree angle, the coordinate of this point right over here is going to be the x-coordinate, which is, we said that's radical 2 over 2. So let me write this in another area. So this is the coordinate of this point right over here. When you create a 45-degree angle, it's going to be radical 2 over 2, comma, radical 2 over 2. And notice how cosine of theta is equal to radical 2 over 2, right? This represents the x value of our triangle, and that's radical 2 over 2. And notice how the y value also represents. The y value is also radical 2 over 2, right? This value right over here. And that means that cosine of 45 is radical 2 over 2, and sine of 45 is equal to radical 2 over 2. Remember, we said that the coordinate of any point on the unit circle is cosine of theta, cosine of the angle you created, comma sine of the angle that you created. So if you created a 45-degree angle, right, and you found out the coordinate was radical 2 over 2 divided by radical 2 over 2, comma, radical 2 over 2, well, then this represents the x value, cosine of the angle you created, 45. This represents the y value of the angle that you created, sine of 45. So yeah, that is your first triangle. The second triangle y'all gotta memorize is, this time what we're gonna do is we're gonna create a 30-degree angle. Once again, you do the same process. You're gonna draw an altitude down, creates a right angle, and this has to be a 30, 60, 90 right triangle, because once again, all sides have to add up to 180, and this is the radius of our circle, even though I didn't draw it that well. So this is going to be equal to, this length right over here is going to be equal to 1. Now remember our 30, 60, 90 right triangle, right? 2x, x, x radical 3. So if this length right over here is 2x, and the side opposite 30 is going to be equal to x, well, to get from 2x to x, just divide by 2, right? So 1 divided by 2 is 1/2, and that's equal to the length of the side opposite 30. The side opposite 60 is always radical 3 times longer than the side opposite 30. So side opposite 60 is just going to be equal to radical 3 times 1/2, or radical 3 over 2. That means that the coordinate of this point right over here is going to be equal to the x value, which is radical 3 over 2, comma 1/2. And that means that cosine of 30 degrees is equal to radical 3 over 2, and sine of 30 degrees is going to be equal to 1/2, right? Remember, we created a 30-degree angle, and the coordinate of this point is sine of the angle that, remember, we created a 30-degree angle, and the coordinate of the point right over here, that when the ray intersects the unit circle, right? When this ray intersects the unit circle, the coordinate where this ray intersects this unit circle is just going to be cosine of the angle that you created, so cosine of 30, comma sine of the angle that you created, sine of 30. So in this case, cosine of 30 has to be equal to radical 3 over 2. Sine of 30 has to be equal to 1/2. Finally, the last right triangle, very similar to the one that was before, except this time you create a 60-degree angle. So once again, draw an altitude down. This creates a right angle. So we draw an altitude down. This creates a right angle. This side's going to be 30. And let's begin. Right, hypotenuse is 1. And now, if we go back to our 30, 60, 90 right triangle, we know that the side opposite 30, so this side right over here is going to be 1/2, and the side opposite 60 is going to be radical 3 over 2. So that means the coordinate of the point where this ray intersects the unit circle is going to be, it's going to be 1/2, comma, radical 3 over 2, right? X, comma, y. We also know that this point right over here is equal to cosine of the angle that we created. In this case, we created a 60-degree angle, comma, sine of 60. That means that cosine of 60 has to be equal to 1/2, right? That matches up. Sine of 60 has to be equal to radical 3 over 2. That matches up. So in short, these are the three points you have to remember. This one's kind of messy, so I'll just write it out. So cosine of 45 is going to be equal to radical 2 over 2. Sine of 45 is going to be equal to the same thing. All right. So just like a quick tip, if, in the future, if you see a radical 3, just know that we're going to be dealing with one of the 30, 60, 90 right triangles, okay? And if you see a radical 2 in, maybe future trig problems or something like that, just know that it's probably going to be involving 45 right triangles. So just keep that in mind. Now, here's the fun part, or maybe just the tiny bit more exciting part. How do we take, let's say, cosine of 135 and sine of 135? How do we do this, right? Well, now we're going to take the big boy angles. So here's the thing. If we create a 135-degree angle, it's going to be somewhere here. The reason why is, right, if we create a 90-degree angle using this side as the base of our angle, this is a 90-degree angle, and 135 is greater than 90 degrees, right? 135 is greater than 90. Therefore, our angle has to be somewhere over here, right? Let's just say this is a 135-degree angle. If this is 135 degrees, well, this angle right over here has to be 45 degrees, right? This angle right over here has to be 45 degrees because, supplementary angles, and they have to add up to 180, right? A straight line has an angle of 180 degrees. So if one part's 135, the other part has to be 45, because 135 plus 45 gives you 180. And now we're going to do the same process as before. Look, this ray intersects the unit circle, and we're going to draw an altitude down. And we said that this is also a radius of a circle. This is also a radius of a circle. And now, we can apply what we learned. We said that when we created a 45 degrees angle, when we said we created a 45 degree angle, we said that the coordinate of that point is radical 2 over 2, comma radical 2 over 2, right? So this point right over here has to be, okay, I know it has radical 2 over 2. It's going to be radical 2 over 2, radical 2 over 2. But the only thing you have to add is this negative sign, and you're done. Because think about it, right? If you're going this direction, if this point is in right over here, this direction, right? This is the negative x-axis. This is negative x-axis, right? Right. If you have a graph, right, and you have a point that's over here, obviously the x value is going to be negative and the y value is going to be positive, right? So in this case, the kind of value, the absolute value of the number that we saw before, right? We're still going to have the radical 2 over 2. We're still going to have the radical 2 over 2. But then all you have to do is just put a negative sign in the front of the x value, right? The y value is still positive here, but the x value is negative here. Let's say if we have, let me just show y'all another example. Let's say if we have cosine of 225. Let's say if we have sine of 225. 225, if we use this as the base of our angle, 225 is going to be somewhere here. This is 225. Now we established that this angle right over here is 180, which means that this angle right over here has to be 45, right? Because 180 plus 45 gives us this 225 degree angle that we're looking for. So this angle, this tiny angle right over here, has to be 45 degrees. And I forgot to draw my unit circle. So just pretend that I had the circle the whole time. Now, once again, remember, when we draw an angle, this ray is going to intersect the unit circle at some point. And we're going to draw, in this case, we're going to draw an altitude up. All right, so if your triangle is above the x-axis, you draw an altitude down. However, if your triangle is below the x-axis, so if it's somewhere over here, you draw an altitude up. Remember, the triangle always has to hit back on the x-axis. That's how I kind of remember it. In this case, this triangle has to hit back up on the x-axis. This is a radius of a circle. It's going to be equal to 1. And this is a 45, 45, 90 right triangle, right? Because we said this is an altitude, which is just this right angle. So this has to be a 45, 45, 90 right triangle. And remember, when we said we have a 45, 45, 90 right triangle, right? We said it's radical 2 over 2, comma radical 2 over 2, right? So this point right over here has to be radical 2 over 2, comma radical 2 over 2. But now, I'd like you to visualize this. So if you have a point somewhere down here, right? Our point is somewhere down here, right? Our x value is going to be negative, and our y value is also going to be negative. So therefore, our point is actually negative radical 2 comma 2, comma negative radical 2 comma 2. And we're done. So that's cosine of 225. So cosine of 225 is going to be equal to negative radical 2 comma 2, and sine of 225 is going to be negative radical 2 over 2. All right, and for the previous problem, cosine of 135 is going to be negative radical 2 over 2. Sine of 135 is going to be the positive version. So kind of the key point to take away here is that once you memorize the coordinates of these types of triangles, you memorize these coordinates, all you have to do is just put a negative sign if, depending on where this triangle is created, right? If I create on the unit circle a triangle here, the x value and the y value are going to be positive for this point. X value is going to be positive, y value is going to be positive as well. If I create a triangle over here, well, notice how the x value in this case, the x value is now negative, but our y value is still positive. If I create a triangle down here in the third quadrant, for this point right over here, my x value and my y value is negative. And then finally, if I create a triangle here, my x value in this case is positive, but this time it's my y value that's negative. So all you have to do is just memorize these three triangles, memorize the coordinates, right? These values, right? And then when you see a triangle like this, so let's say if I wanted you to find out cosine 225, well, we know that this involves a 45, 45, 90 right triangle. So all you have to do is just kind of substitute the point in, and then after that, just put a negative sign depending on where the triangle is graded. All right. Once you memorize all of these values, the work is basically done. You just have to put a negative sign depending on where the triangle is, and that's basically all your work. So that is how you do these types of problems. So we're going to do one more problem. Let's say that I want to find out cosine and sine of 240. Right. So a 240 degree angle, where's that going to be? Well, 240 degrees, that's 90 degrees, 180 degrees. 240 is going to be somewhere here. I'm using this as the base of my angle. Now, when you have a 240 degree angle, right? If this angle right over here is 180 because it's a straight line, this angle right over here has to be 60 degrees, right? Because 180 plus 60 gives me 240. So this is going to be a 60 degree angle. And now, when you look at that, this ray touches this unit circle here. We draw an altitude up, right? Because remember, we have to draw an altitude depending on where this x-axis is, right? If our triangle is upwards, we draw it down. If our triangle is below, we draw it up. Notice now we have a 30, 60, 90 right triangle. Now we said that when we create a 60 degree angle, the coordinates are going to be 1/2, comma, radical 3 over 2, right? When we create a 60 degree angle, the coordinate right over here is going to be 1/2, comma, radical 3 over 2. Right? We established that before. But now, all you have to do is just determine which of these are negative. And if you have a point right over here, both your x value and your y value are going to be negative. Therefore, you just have to put a negative sign next to these values, and you're done. So cosine of 240 represents the x value of that point. So it's going to be equal to negative 1/2. Sine of 240 represents the y value of that point, right? Remember back to our first theorem we talked about, or rule. Sine of 240 is going to be equal to negative the radical 3 over 2. And we're done.